talk a little bit about some of the logistics of our AI panel that will be happening during lunch, and then I'm going to bring up our great panelists. So the AI panel format, we have 3 awesome panelists for you guys, and how it's going to work, each of the 3 panelists will give a 15-minute talk, and then afterwards we're going to have a Q&A session with them for about 30 minutes, and then that'll take us to about 1 o'clock. And then we'll have a little break time for you guys to go to visit booths, relax, and then we'll get back into the breakout sessions. So the questions will, we won't be taking audience questions during the session, but we really do encourage you to go up and approach any of the speakers you have questions about afterwards. They will be here throughout the day so you can track them down. So the speakers, I'm going to let them introduce themselves and their background a little bit, but I will now bring them up and kind of introduce them in turn, and then we'll hear their great content. So first, I have Dr. Wei Xu from The Ohio State University. She's an assistant professor in computer science. So welcome, Wei. And then we have Joy Kenyon from Cardinal Health. So Joy will tell you a little bit about her background. And then we have Abaya Lothan from Magellan. Awesome. All right, you guys want to just have a seat? And then, so here's your clicker. So Dr. Wei Xu is going to kick us off with some of her content. Then we will move into Joy, and then Abaya. And then we'll have some questions. So Wei, I'll let you take it away from here.
Okay. So I'm Wei. I'm from Ohio State University. So I'm an assistant professor in the computer science department. My prime research area is machine learning and natural language processing. So I'm going to talk a little bit about the research we are doing in my group. So we have heard about Turing test. I don't know how many of you actually see the original paper. So this is a scan of it. You may be able to read a little bit of there. So it's kind of an interesting idea about Turing test is like how to interpret the question, can machine think, and how we actually test it. The great idea Alan Turing come out is that I shall replace the question by another's. That's an imitation game. It's boiled down to another question is really, can machine actually conduct natural language conversations just like a human? Can fool the evaluator, who is a human, that whether this is a computer is talking, he or she is talking with, or whether it's a real human being he or she is talking with. So that's the whole idea about Turing test. So the idea is coming from like 1950 from this published paper, and I guess Turing died 4 years later. And not only until 1956, the phrase artificial intelligence was coined in the Dartmouth conferences. So that is to say, understanding and generating natural language processing has been always a quest for artificial intelligence. So this is a plot just showing you that how many researchers, world-leading researchers actually in this area. So we have a global organization called Association of Computational Linguistics. So it started about more than 50 years ago in the US. And this is the number of members of this research organization. So you can see it's kind of steadily growing, but it's not like suddenly it's like we become so popular. We have been popular for some time. We currently have about like 3,000 members globally, and about 1/3 are from US based. And among these 3,000 members of last year, 1/3 are students. So the rest are from researchers from industry or people like me who are still in academia but no longer students. One of the questions I often got is really, so what is your ultimate quest? So what's the ultimate problem you want to solve? So I really find it fascinating is that human language is so interesting in terms of it's difficult, in terms of it's like ambiguous. This is like students, this is actually a real news article. Student cook and serve grandparents. This greatly difficult for a computer to understand and process it correctly. And human language can be very creative. So this is actually a real data our model can capture. So it's a Jeremy Corbyn is a closet Brexiteer. So Brexiteer is not hard for any human being to understand if you're an English speaker. However, it's a great difficulty for a computer to deal with it unless it's showed in the training data. But this is, I mean, things like this keep coming out, and this like the closet, like Brexiteer, is a very smart way to use language, but I mean, the computer is just not smart enough for us to really understand it fully. And also another concept I would like to mention is the infinity of a human language. So we only have like a small vocabulary. For English, we normally just use about 10,000 or 15,000 words in our daily life. However, the sentence we compose from it is unlimited. So the sentence I'm speaking today and as you speaking today, that sentence very likely be the first time being heard in the human history. So this makes it incredibly difficult to build computer software to fully understand or even generate it. Another idea is like the human language are evolving. So the word we use like selfie, we take it for granted, but it's only coined in about like 2003, according to Wikipedia. But you can say that like, this is like the Google trend. It's only really become popularly used not until 2012. So that's meaning we coin some word and phrase, especially like some company names. Like you can say the startup company names is become more and more creative because they run out of the choice. They want to be like you often want just like one single word, but not too long, but something kind of pronounceable in English. It's running out very fast, and the more and more weird company name coming out, it's very hard to identify them like automatically. So this is what one of the solutions we provide. This is one of my major research areas. Of course, my group do all kinds of machine learning applications. So the algorithm I'm going to show you just for the next several slides are not only applicable for the task I'm talking about today, but actually generally applicable for other areas. For example, computer vision, we share a lot of algorithm in common. So the solution we provide is really like trying to learn a large scale from large scale data, and in particular paraphrase. So what is paraphrase? Paraphrase can be word, like selfie to photo is a paraphrase. And it can be phrase, get a boost from, has been sacked by. So this is actually the real data we captured by our models. You can see that get a boot from is pretty difficult for a computer to understand, or even, for example, this is a very difficult cases for machine translation. So it's like no way you can cover all the idioms you come out, and those are the most difficult to actually for a computer to process. And it can be a sentence, the example I have already presented. So those are the what we try to learn automatically from just from a large stream of data. Just give a little bit example how actually it's being used. So I hope most of you already know that the IBM Watson question answering system, which beat human Jeopardy champions in 2011. So the question answering system, one of the biggest component is paraphrase. It's one of the three most important components in the system. So to answer a question like who is the CEO stepping down from Boeing, it's really we need to understand that from the news articles, recognition is also mean the same as the stepping down. It can be like ousted. So there's so many numerous ways you can express the same event, but how to make computer to be able to match it is totally rely on whether you can know that whether it's a paraphrase or not. This is another great example. So Newsela is a startup company I work with, which is based in New York and California. So it's an education tech company who provide curriculum material for elementary school and middle school. So the general idea is to provide news articles that bridged into simpler language or grammar for children to read, to get access to the latest news in various domains. And they currently hired a lot of like professional editors to do this process. You can see on the left is the original news article, and on the right is the simplified version. So our system is really to use an automatic machine translation system to do this process automatically. All right, so I'm going to move on to talk a little bit how we actually do it. One, I'm just going to give two examples that are representative of the two most mainstream machine learning algorithms. So one is probabilistic graphic models. So this is an example. I'm not going to go through too much detail about it. General idea is like you have variables for the sentence pairs, and the Z variables are all the word pairs, and we try to model the semantic relation between the two. The particular technique used here is a multiple instant learning idea. So that's how you connect the sentence layer and the word layer together, and you'll try to optimize the overall probability. And there's a little bit trick displayed, and using the weighted view approximation and long line learning to make this process extremely fast. So this whole model is extremely fast, just within minutes on a laptop. Another great example, basically the other only choice of machine learning algorithm is neural network. And you also heard it's kind of deep learning, although the word deep is not to mean it's sophisticated. Its meaning is just simply deep, but have multiple layers of model network stacked together. You know, the buzzword is always two-word phrase like big data, data science, artificial intelligence, and machine learning, deep learning, and it just changes like every 3 years, and kind of my research fit in all of them. So whichever one come out, and we're just going to throw that onto our paper and proposal. That's about it. So this is an example of the model. So I'm going to walk through a little bit of the details here, just to give a showcase of how we actually do it as academic versus like industry solutions. So first of all, we start from the very basic input layer. This is just two sentences. Of course, this is extremely simple and short sentence. The real sentences are much complicated. I just cannot fit into the slides. So we'll just go with these very short sentences. So we try to model the context. You can use various solutions. You probably heard a lot of word2vec, and you can use Glow. That's another version of it, similar thing. And of course, you can make more sophisticated. We can use subword models and have convolutionary like neural networks and with a heavy network to make it much better. That's actually the newest paper we have just this year. It's just accepted. So this gives you a preview of what the state-of-art models look like. You generally use a bidirectional long, short-term memory neural network in order to put them together. You can do a tree LSTM to use the syntactic information, which helps sometimes. So the whole idea is to break down the sentence pairs into word and also carry on the context information. And then you're going to calculate the similarity between word pairs between these two sentences. So you can see this is just one side is a matrix, so one side is one sentence, the other side, the other sentence, you'll use some like cosine similarity to calculate its similarity. And you can just come out of the tensor after all. So tensor basically, so matrix are 2D, and the tensor is just a 3D representation. This is how you model the interaction between the word. This next layer, you can just add some attention, so which is the greatest neural network architecture, really work well. That's how you'll see that Google machine translation, they really rely on this. We do something similar. We add some hard attentions onto it. This is just one way to do it. There's multiple choices. So to enforce which are the word really matters. And then at the end, for this particular model, we apply the deep convolution neural network. This is particular one. I have a lot of layers. And aggregated all the information together and to make a conclusion. So that's about it. This is another example coming out of our research on paraphrase. This is like the different words that mean about the same, but speak differently on the, based on the human data we can collect on Twitter. So female users tend to use wonderfully, and the male users choose some different word. So this is a great example in terms of like actually user profiling is big industry because of the marketing values there to identify who are the users are, even they don't put it onto their profile in order to displace the right advertisement to it. So my Twitter profile is always identified as male just because I talk mostly about my work in computer science. However, so most of the current state of our models are rely on the topic word kind of. So that's meaning if you say like my husband going to indicate you are a female user, things like that. But in this particular research we do is really to identify from your language style. So no matter what topic you talk about, the word choices cannot tell a lot of who you are. And actually after this research, I start to use word superb when I reply emails. This is another example of what we do. Of course, the paraphrase is only one thing we do, so which is one of the projects supported by National Science Foundation and Defense Department and Craftflower, another startup company based in San Francisco. So we are currently receiving over $500,000 of research funding for the project I just talked to you. And this is another example of latest work. Also, like you can see, it's published at NACO conference 2018, so it's going to happen just in June this year. So we haven't presented work elsewhere, so you got the how to say, the worldwide primary here, right? Yeah, so this is like really try to interpret wet lab protocols for the chemistry and the biology to convert it into a machine readable form in order to automate it. So that's all I have for you, and okay, I flipped over too much. I'm going to hand it to the next speaker.
Thank you, Wei. So good afternoon. My name is Joy Kenyon, and I am a director of software engineering at Cardinal Health. And today I'd like to share with you a little bit about our journey to implement an artificial intelligence strategy at Cardinal. So when we began to explore the opportunities with AI, I mean, obviously you are aware those opportunities are just simply abundant. And when we began to look at how we capitalized on those opportunities to build a strategy, there were really two things that rose to the forefront for us. We knew that AI could help us to lower our cost and drive efficiencies, but that it also, and most importantly, could help us to improve our delivery of care. Specifically, we felt that it could help us to get the right product to the right patient at the right time. So we began to explore AI within our commercials technology division at Cardinal Health, Fuse by Cardinal Health. You may have seen them at their booth out here today. But our Fuse organization is responsible for bringing commercial technologies to market, and they also serve as an innovation and R&D hub for technology within Cardinal. So they began to explore AI, and what they found was that 80% of the use cases that we have at Cardinal Health truly fell into the category of supervised machine learning. So there are many different applications of AI, machine learning being one of them. And my simplistic way of defining machine learning is simply machine learning is an algorithm, much like you would use within analytics. But the difference being is that we feed data back into that algorithm so that algorithm could learn and grow and provide better outcomes. And so, as I mentioned, 80% of the use cases that we were exploring really fell into a category that could be solved with machine learning. We also had a rich abundance of data within Cardinal Health that had both events and outcomes that could be used to help train a machine learning model. And we also had very well-established analytics practices. So we had strong networks of people within our organization who had the foundational skill sets required to begin building a machine learning practice. So while we were making great strides within our commercials technology division to explore use cases around machine learning and even begin building some models, we wanted to be able to expand that out into our broader organization, make machine learning enterprise-wide. And as you can imagine, machine learning was definitely the hot thing within Cardinal Health, right? It was, in our words, a hammer looking for a nail. It was the one thing that was going to solve all of our problems. So if you look at a typical hype curve, we were definitely at that peak of inflated expectations. Machine learning was the answer. And we wanted to be able to get our enterprise very quickly from that peak of inflated expectations to the plateau of productivity. And that can be very overwhelming with an organization the size and scale of Cardinal Health. So we felt that the best way to introduce machine learning to the masses would be for us to partner with a third party to help us pilot a machine learning use case, so then we could then prove to our business stakeholders not only the value that machine learning could bring, but then also what's the appropriate use case for where a machine learning solution could be applied. So we were looking at partners in the market that could help us not only select the right tool sets, but also help us to develop our talent, and then teach us the methodology that we needed to incorporate to be able to build that minimal viable model that would be appropriate for the right use case and demonstrate that value to our business. So while there are many different players in the market, many different partners that you can choose from in the market that may offer such services, we chose to partner with Google to begin building an initial pilot to build that minimal viable model. The reason why we chose Google was not only for their maturity in this space, but also their vast access to data. We felt that they could bring us insights that we may not even be aware of. They may help us to answer questions that we may not even know to ask. So we partnered with Google to build that pilot, or to initiate that pilot, to build that minimal viable model. And we realized we wanted to be able to capitalize on this excitement. Again, we're still at that peak of inflated expectations with machine learning. And we wanted to be able to take that momentum and make machine learning part of the Cardinal Health culture. So one way that we decided to do that was to formulate a machine learning guild. And I absolutely love this definition of a guild, so I'll let you read that. But I don't want the irony of the picture to be lost on you. If you see this picture, this is the first group of developers who developed the first Macintosh. So one of our great modern day examples of a guild. And the guild at Cardinal Health, what we do and the services that we provide is we bring together people who truly have a passion around machine learning, who want to learn more. And we hold monthly meetups where we'll either bring in external speakers or even showcase groups within Cardinal Health who are working on various machine learning applications. And these monthly meetups are intended to just be knowledge sharing sessions, opportunities for people to get together, ideate, discuss, and learn from one another. We also hold quarterly hands-on workshops where people can come and actually get experience with machine learning. They can try to build their own model. They can learn what it means to train or to test a model. So we give them that opportunity as well. And then we also provide training tracks. Our mission is really, to bring machine learning, to make it part of our culture. We want everyone, regardless of rank or role, to understand not only the value that machine learning can bring, but then to be able to apply it appropriately. So we offer two separate training tracks as part of our guild, a technical track for our developers, as well as a functional track for our business leaders to be able to get a better understanding of what machine learning is and the value that it can bring. So now, we're still very early on in our journey. So, we're experimenting within Fuse, within our commercial technologies division. They've already started to produce some great results. We're holding our meetups and our hands-on workshops through our guild. And we're really working very hard to bring that mainstream. Even though we're early on in our journey, we've started to see some amazing things happen. we've started to see groups across the enterprise, not just within IT, but business groups, business leaders, operations, sales, begin to experiment with machine learning, which is absolutely astounding. And one of the great use cases that I want to highlight, our group within Fuse began to explore opportunity with one of our businesses, our direct-to-consumer medical supplies business. So what this business does is we ship medical supplies directly to the consumer, and then we receive payment from the payers on the back end. So we'll get reimbursed for that product that we ship out. We have a very real problem today where we ship approximately 10,000 items every single day, and of those 10,000 items, 125 items are never reimbursed. So this is an incredible amount of lost revenue that we have. Our group at Fuse was able to put together a machine learning model that can predict with a 90% accuracy rate whether or not that shipment will be reimbursed. So on the whole, this is going to save us approximately $1.2 million in revenue every year. So that is just one great example of the power that machine learning can provide. And I invite you, if you're interested in learning more, definitely stop by the booth and talk to our great folks from Fuse who are here today. They can share more about what they did for this particular use case as some of the other great opportunities that they're exploring with machine learning. And with that, I'm going to turn it over to Abaya.
All right, I'm very low tech and have to look at my notes. So, my name is Abaya Lothan. I'm a Vice President of Advanced Health Analytics at Magellan Healthcare. I report up to our Chief Medical Officer. My team is responsible for devising machine learning models for our clinical pillar of care, as well as modeling quality outcomes. And just recently, last year, we also inherited our member and patient sentiment and satisfaction analytics with the company. We work really closely with information technology at our organization. I think the ability to do analytics has to be extremely tightly embedded with the data organization that is at the company. And together we work toward better and more integrated application of Magellan's data in clinical models and then operational models as well. So let's talk about AI in healthcare and why it is a disruptive opportunity. So when you look at these graphs, what do you see in terms of what's happening with cost? You'll see that cost is going up. And the very interesting thing about this is that the Congressional Budget Office, which is the source of this data, projects that spending on healthcare via Medicaid, Medicare, the child health CHIP plans, and healthcare subsidies is not spending that is going to shrink or stabilize through 2047. That's actually 17 years past the flexion point that we're currently in right now, where we have people aging, where the baby boomers are aging into Medicare. There's like 25 of them every 5 minutes or something like that. So 17 years past that point, we're still going to be seeing this upward growth of per patient costs in healthcare. So I think that's going to cause a lot of anxiety for any payer. It should cause anxiety for patients because most of you are experiencing, I think, higher deductibles. There's greater cost shifting onto the patient in healthcare. For payers, if we want to remain solvent in this new reality, then there's a critical need for us to get very smart about how we deliver care and how we manage benefits for our patients. And the good news is there's a whole lot of potential energy in the market that we can harness to achieve some changes. Even in a case like healthcare, which has been more resistant than most industries that I think modernizing and getting on the big data bandwagon. when we look at how patients, and which we call members in the healthcare space, but I'm a recovering epidemiologist, so I still refer to them as patients. We can use measures like Net Promoter Scores that help us assess how likely someone is to recommend the company to friends, family, colleagues, and things like that. So I'll give you an example. A company like Amazon, a Net Promoter Score is usually ranked from like 0 to 100. And a company like Amazon ranges between like a 70 and 80% Net Promoter Score. That's pretty good. Healthcare, on the other hand, your insurance company is doing well if it's above a 20. So, we believe that patients have an appetite for us to change what we're doing. And I think likewise, there's frustration for physicians and providers as well. If you sat in to Dr. Amstutz' talk, she touched on this a little bit. If you are an Ohio State student that resides in Ohio, and let's say you go to Miami for spring break and something happens and you have to go to the emergency room, your physician there in Miami is not going to be able to access your healthcare records from your provider here in Ohio. And likewise, when you return to Ohio, your physician here will not know that you went to the emergency room in Miami unless you tell them. And there's no solid information exchange between those two providers. So even though we're in an environment where electronic health records are kind of, de rigueur in the market, there's lots of different platforms and they were not designed to talk to one another. So that's a big barrier. We also have new entrants into health technology. So the Internet of Things, my Apple Watch, your Fitbit, Alexa devices, home speakers like Google and Apple. These are all devices that are networked, and they capture a ton of information about us, about our personal habits, the environmental characteristics in which we live, the social characteristics of how we interact with one another, how we interact with goods and services, and they can together be linked to start changing how we deliver health. So the way also in which we consume services has really changed. And when we're thinking about healthcare, we're often thinking about it in the old way, where you go see your doctor says, you really need to watch what you eat. But in order to really change your health, we need to change your health behavior. And we're in an environment where our behaviors, our consuming behaviors and our actions are being shaped by these technologies that we have. So I can get apples, my husband's favorite type of apple, delivered to me via Instacart. And now I have a therapy app that I can put on my phone. So when I'm sitting in the carpool lane doing nothing, waiting for my son, I can actually check in with my therapist and let them know how my insomnia treatment is going. So the whole concept of how I am consuming healthcare, how you can consume healthcare, is totally changing. So we've got this explosion of information that can feed an AI. We've got a willing market ready to try new forms of delivery, and we have strong market pressures, I would say, to get with the program. So I think this is an ideal situation for AI to flourish. So I think we talked about this a little bit, the other panelists have as well. A lot of times in the market, we use the term AI, but that really is an umbrella term for many specific tasks. And AI can perform social manipulation, it can do intelligence amplification. Those are things, for example, where you have machines reading MRIs or CT scans and offering diagnostic information to providers. A provider can't sit and read peer-reviewed journal articles every second of the day, but an AI machine can essentially read those in and provide that intelligence amplification to the provider at the point of delivery of care. They can help create strategies for changing behavior. They can hack. Now, in the totally sci-fi application of this, it means, I would get my genome sequenced, and if I have the replicant of liver enzyme, that means, I process things or I metabolize certain products slowly. In the sci-fi application, my gene could be altered. But I think a more realistic and immediate application of that is that we can use some of the Internet of Things tools to help shape behavior in ways that will change outcomes at the patient level. We also have the propensity to do more technology development. Big pharma is out there spending tons of money on research and development, and why not have AI tools that can crunch data and identify key populations that need new products to be developed and delivered, making big pharma more responsive to the actual needs of the population. There's also decision support, which is available at the patient and the provider level to help kind of show, here's all of the treatments that are available based on this patient's social determinants of health, their customized responsiveness to certain products and things like that. Here are the treatment options that we think are going to be most effective. And here's some that are going to be most cost effective for this patient who is a Medicaid patient and doesn't have the economic mobility of someone that may be commercially insured. And then finally, there's machine learning. Any AI has to have the capacity to learn. And so we're going to need machine learning to be kind of a constant piece of that. A highly functioning AI, a true AI, of human level AI, will do all of these things. But I think we're a ways from getting that to work. So I think where we are in healthcare is with this need to develop, all of these different tasks until we have finally a master algorithm that can unite them all. So when we talk about AI in healthcare, I like to phrase it, this is a physics problem for us, right? Our goal is to take a patient where they are and move them to a more healthy state. When you think about this historically, it's just been you go to the doctor, you have a problem, the doctor notes that, maybe your blood pressure is starting to creep up, and so they just say, keep an eye on that. Well, what does that mean? What if you had the ability to go home and Alexa, instead of having your doctor just say, keep an eye on that, Alexa developed a custom meal plan for you to help you reduce your salt intake over time, and then had you check your blood pressure, report it in every morning, and then track how it declined over time. To me, that's the physics of the healthcare problem that AI can solve. So we want to be able to amplify physician intelligence by showing probability, provide confidence intervals of diagnostic accuracy. We want to provide physicians and patients with what are their predispositions to adverse health outcomes. For example, for most of you, do you know what the health outcomes are based on where you live? Some of you based on where you live, like I, for example, live in Colorado. Colorado has actually one of the healthiest populations in the United States. Mississippi, on the other hand, has some of the unhealthiest patients in the United States. So where you reside, those social determinants, those impact your health. If you have asthma and you reside in an area near a factory, you may live in a high particulate area that exacerbates your breathing issues. So again, AI and these tools can help inform patients and providers what those risks are, and then design treatments and interventions that can help minimize those risks in the patient's life. So I'm going to skip ahead, actually. I think we've talked a lot about the rewards of AI. There are many rewards, but I think there are a lot of risks as well. I think we can kind of really divide them into two types. The first are barriers to implementation. So first and foremost, I think many of the folks in this room are working on this. There's a barrier with the integration of data, and I talked a little bit about that at the beginning. The way in which our provider electronic health records don't talk to one another, the way in which states capture information about us, your credit card captures information about you. There's lots of places where information is gathered, but it is not synchronized together. And ultimately, these models need to have that data combined, cleaned, and have it be accurate and readily accessible real time. So to harness the incredible volume of data and unify it, we know we're going to have concerted effort, and we're going to have monetization in order to achieve that goal. The other thing I like to think of is I like to think of in 3D printing of AI as, kind of the scaffold. And then I like to think of health and community interventions I don't know if you guys remember when they 3D printed the ear. So they 3D printed the scaffold for the ear, and then they laid stem cells over that scaffold to grow the ear. And so I think of community health and healthcare delivery, those are like those stem cells that will lay over the scaffold and grow something that changes the patient's trajectory of care. Right now, there are lots of community organizations that contribute to patient health. Organizations like Alcoholics Anonymous, food banks, lots of things like that. They are not integrated in that way in their data at all. And in order for us to be as efficient as possible, we're going to have ways to share data with them and get data from them so that we can help push, the patient from point A to point B with minimal intervention on their part. And then I think also AI itself is still imperfect. So if we're going to achieve this blue sky ideal, the processing power that we're going to need is going to be immense. In healthcare, the processing and modeling needs are also very unique. They're governed by privacy issues. They're governed by other federal and local and state regulations. And right now, there's not one system that can currently meet all of those needs. We also have exponential computational processing power needs and new mathematical models. I think one of the challenges as well is that in health, you need to know causation and not just correlation. And some of our machine models are still challenged with picking those out without human intervention or oversight. And I think the final type are what I phrase as risks. So AI has to be developed right now by people. And any such models we devise are liable to be prone to the same mistakes of logic, attribution, and bias that we ourselves have. So I don't know if you guys read the news last year, but in August, the University of Virginia had developed an AI that was consuming stock images. And they noticed that a pattern was beginning to emerge where if they had presented the AI with a photograph of a kitchen, the AI was like, that's related to women. And if they presented the AI with a photo of a coach, they related that to men. Well, the problem is that the stock images that the AI was consuming reflect that social bias, right? And unfortunately, in that case, the AI was taking that and amplifying that bias. So, their AI is not the first to have this problem. And we need to look no further than the financial crisis of 2008 to see the ways in which amplification errors of intelligence in models can really cause complex, large problems. Another extension of this is to think about infant mortality in Medicaid. In Medicaid, infant mortality rates approach that of third world nations in the United States. If we design an AI tool that ingests how it has been in the past and asks it to predict the future, we can basically replicate the tiering and lack of access, I think, that we have right now in our healthcare system. And so I think that the models that we need to build have to have properties that allow porousness and allow patients to move from a low health status, low health access into more sophisticated and more equitable access. So there's a lot of rewards we can reap here, from bias elimination to move towards single tier healthcare provision. And I don't mean single payer. I mean that basically no matter your economic standing, that you receive the same healthcare as everyone else. I think we can also achieve behavior change. And I think that's going to be the most critical piece at changing health outcomes in the country. Health equity, I would love to also see the ability to tune our environment more to be more sensitive and responsive to health needs. And last but not least, cost containment. So that's it. Thank you.
All right, well, thank you to all of our amazing panelists for their talk. Hopefully gave you guys a sense of kind of backgrounds, and we really have kind of covered a lot with the different talks, so strategy, technical, organizational. So my questions will kind of dig into all those various aspects. And my goal is for us to kind of have a conversation, and if anything piques your interest, please track down one of the speakers afterwards. So one of the first questions I wanted to ask was, you all kind of mentioned some serious challenges in implementing AI as a solution, right? And those challenges can look different for different areas. So whether it's an organizational challenge, a data acquisition and sharing challenge, which is something that is essential for any AI or machine learning strategy, technical or policy restrictions. So basically, in your kind of various experiences to date within your organizations and within your academic research, what has been successful in kind of approaching and overcoming these challenges, and what really hasn't? And this could, kind of be, things you guys have experienced, or maybe that you're currently have in the works that seem promising. So Joy, I'll let you kick us off. Yeah.
Yeah, I think there's a misconception that AI is easy, right? When we want to start an AI practice, or we think we're going to launch into AI, we immediately want to go to building the self-driving car. I don't think people often realize the complexity. Abaya made a great mention to it. If it were really that easy, we would have these autonomous robots who could cover all aspects of AI, which someday we aspire to. I would love to have that robot to do laundry, but instead I have children. So, but it's not that easy. And so my advice in that regard is we have to start small. Work on small, manageable pieces of the puzzle to be able to build that competency, to build that practice, and begin showing that value in those small increments. You're not going to get to building the self-driving car overnight. It takes a lot of work and effort. So I think it's just about managing that scope, as you begin to build that competency within your organization.
Anything else you guys want to add to that? I think those are some excellent points, starting small and conveying that this takes time. Yeah.
I think you have to have a good sense of what your goal is, and then you can build. I think the biggest issue is going to be data integration, as I've been beating that drum. Mm-hmm. And kind of the concept of knowing where you want to take it, and that will help you organize the data in order to answer the questions that you want to answer. You kind of constantly have to be looking ahead instead of just focusing on a reporting ask, or something like that that's very sort of immediate. You need to constantly be building to the future.
Well, I guess in this sense, academic has a lot of advantage for us. I choose what data I work with, and we normally go with the open source data in order to make the biggest impact of our algorithm design. It's not the machine learning algorithm we develop is only can work the particular data we have. It's more like a demonstration of what it can do. So a lot of research we do, for example, we'll work on Twitter data. It just given the text data, this is like abundantly available. There are millions of tweets we receive every day, so we can really use a lot of data as much as we want. I think that's probably one of the interesting things to work in academia, and also encourage you, if you work in private sector, to actually share your data with the researchers. It actually can help a lot. So that particular company I mentioned, Newsela, which produces like simplified news articles, we started collaborating with them when they were really tiny companies. Now they grow to like probably 100 people now. So we convince them to share the data with us, and we publish paper on it, and we use their data to train the automatic systems. So now it's become a world standard for this particular research area, and they shared with a lot of research groups in the world, and they have the free access to the intellectual property of the content, and they can actually any researchers in the world publish something on their work, they can just apply that techniques in their company. So most of the research are free.
So Wei, I just wanted to follow up on that. I think you mentioned a huge source of data, open source data, that is probably of great interest to a lot of companies in the room. And I imagine utilizing Twitter data takes some time and thought, right? So is there any kind of big picture kind of steps or infrastructure that you think might be important for companies to start thinking about if they want to start leveraging insights from available data, social media data, Twitter, Facebook? What sorts of big picture infrastructure or strategy changes should they have on their radar?
Is by sharing the company's own data or to utilize the social media data?
Utilizing open source data that might be out there about the company, yeah.
Yeah, that's a great question. So normally for Twitter, it's like for academia, we have some certain limit we can use freely. I think for companies, that you have to read the terms and and they normally you have to have a license from them and you really have to pay for kind of like Twitter data. That's basically the case.
Yeah. So it's kind of the big starting point then.
I don't think I don't know how much it costs, but I think it's fine. A lot of research groups like Microsoft Research and Amazon I collaborate with, they all have access to it.
Great, thanks. So another question I had for you all, and Abaya and Joy, you guys kind of made me think of this one. How do you, within your kind of leadership and even within your teams, how do you delineate a good machine learning use case from something that maybe is better solved by policy strategy or maybe an experiment, especially kind of the looking for that causal, kind of agent sparked my interest in that. So how do you train your teams to delineate the differences there? Like, what do you look for to figure out, hey, this is a great machine learning use case, or maybe this is something we should be thinking about solving with policy?
Well, Abaya had touched on it, and so did Wei. The importance of data is absolutely critical, and we actually spend a lot of time evaluating our data sources and combing through that data to make sure that we actually have the right data with appropriate events and outcomes that could properly train a model. Sometimes there's just not, good quality, rich data that you could effectively use to be able to train that model to achieve the outcomes that you want. So I think first and foremost, looking at the data that you have available, as well as if it's the right data, what type of biases that data might contain, is it the right structure, is it the right quality, I think would be key.
Yeah, so what we've done just over the past couple of years is we create, so we're a clinical organization, so I think our data scientists usually come from epidemiology or biostats backgrounds, but what we have started doing is we'll work with the business and with the clinical team, we'll create a flow. What is the activity? What things are we doing that we intend to influence the outcome? And then what's the outcome we want to measure? We start from there. And then we look at the systems at which we're capturing all the data. So then we can map, okay, this activity aligns to, in this system, it's captured here, and they're supposed to fill out this, and this. And it also allows us to rapidly identify where there are breakdowns in the workflow, which we do a lot, and then figure out whether we just move that, kind of predictor out of the model. But in that way, it's helped us avoid trying to build something off of data that's no good.
So, and then Wei, in kind of academic research, do you, in your lab, do you guys use experimental strategies, or is it mostly kind of combing through data that already exists to kind of test out your new, theoretical underpinnings of your models, or?
Yeah, that's a very good question. So actually, we first of all use a lot of data we obtained from web and all these sources, and my group also create data. So particular thing is like annotated data are kind of more like for training. So you have the ground truth labels normally created by human annotators. So actually, I invest quite a bit of my research funding into creating those data. And some of the data set we created are shared with a lot of companies and research worldwide. So yeah, all the data we created are free. And yeah, we pursue our own data. It's more bigger impact other than just wait other people to give us the data to use.
So hearing all of your responses, and my background is in academia, and now I'm transitioned to business. So I think there's a lot that can be gained from marrying the two communities. And it sounds like way in your lab that you guys have done this successfully. So I'm curious to hear kind of each of yours perspective on what are some of the challenges here, and from an academic perspective, what are some of the opportunities these businesses can think about for how they might be better utilize all of the cutting edge academic research that is happening at institutions around the world, really?
I would have to say that one of the challenges that this space is just evolving so quickly.
Yeah.
And it's difficult for any one organization or one institution to be able to stay on the forefront alone. And so whether that be business partnering with academia, other business consortiums like with what we have through the Columbus Collaboratory, I think us all working together can help us to pool the resources, pool our talent, and achieve more together. One of the things that we've run into is sometimes we don't even know the right questions to ask. And so, being able to get exposure to what other groups are working on and research that's coming out of academia, I think helps to spur new thinking and spur new innovation. So the more we can collaborate, I think the more we'll be able to move forward at a quicker pace.
I really agree with what Wei said earlier, that businesses have to find ways to share information with academics. I think also finding new startups and things like that where you can do proof of concept and other tasks like that. So what we do at Magellan is we create, obviously health data is very sensitive, it's governed by HIPAA, there's lots of regulatory requirements around it. So what we do is we develop de-identified data sets that can be used by other businesses, and we also partner with academics to jointly publish and jointly do research on particular outcomes and things like that. That's relatively new, but I agree. I think that this process has to be democratic, and I think it has to be multidisciplinary, and I think if you're able to do those things, you will be very successful.
Yeah, I had a little bit to add on it. So actually, it's kind of a collaborating anyway. So the tax, the corporation, and we pay. Part of it will support the research in the U.S. and, for example, National Science Foundation, as well as DoD department, are one of the basically the biggest funding resources for research in the universities. So our is may not be a direct collaboration with a particular company, but the students we educated are going to join the workforces at some point. So although the research we do may not directly doing like a industry application, just as these ladies do, but the student we educated, eventually will join the workforces and become the driving force behind all these innovations in the industry.
Great, that's some good dialogue on that question. So what can leaders in this field, whether you're a PI leading a lab, organizational leader within a big enterprise, what do you think you can do to kind of cultivate success on AI and machine learning focused projects? How do you communicate it? How do you convey the time that it takes to think through and build these models and that may ultimately result in kind of some software or big organizational changes? What have you found that allows you to successfully kind of build these solutions? Yeah.
I would say as leaders, the most important thing you could do is educate yourself. And I think today is a great example. Looking across the demographic who's represented here today, we have a lot of great leaders, not only from around Central Ohio, but from around the nation. And that is incredible. So I think just taking those opportunities to educate yourself about AI, machine learning, and just the possibilities and where it's going in the market, I think is an important way.
So I think it has to do with making sure that you have analytics, like an analytic vision. I think Magellan is helped by having a massive transformative purpose. We're here to, lead humanity to healthy, vibrant lives, and so that helps give us a direction of where we want our machine models or our AI models to go. So we're starting with a purpose, and then, together with analytics and with your IT or your data organization, you can start to get the two of them working together, and then analytics can help guide data science folks on how to build what needs to be built in order to, leapfrog to the next analytic delivery and so on. And it becomes this really iterative process that I think will help lead to success.
I think good people, you will find one person, if it's really good, it's probably better than like 100-person team sometimes, especially for like very cutting edge kind of techniques. It's just, there are success. So some of my co-authors when I was a PhD student now, like they found their own startup, just 3-person team, and they sold the company. So it's like you don't need a lot of people, but you just need a few good ones.
So you guys mentioned 2 things I wanted to follow up on. To kind of take them in turn, one is good people, right? I think everybody in this room is interested in finding good talent, good, strong talent. It's really hard to assess in this field, and it's kind of hard to find too. So how do you, when you're assessing, a candidate, how do you go about finding a strong candidate? And thinking of kind of the 2 different roles here, so right, there's the kind of the developer role. How do you go about assessing a strong developer in this space? And then there's also roles that might be more strategic or leadership in this space. So what do you look for in a strong candidate?
I look for the passion. If the passion and the motivation is there, that'll trump the strongest talent any day. We can always teach. So I can, teach someone the skill sets, give them the right knowledge to be able to be successful. But if, they don't have that motivation or that passion behind that's driving them, then, they won't be as successful as someone who does.
I only hire PhD students. And it's funny enough, as I showed you, that in the worldwide, at any particular time, there's about only 3,000 researchers, and 1/3 are students, primarily PhD students. And in my career, for any very successful professors in academia, until we retire, we normally can groom like only about 30 PhD students in our entire career. Generally speaking, I hire 1 or 2 PhD students per year. So it's a very tiny kind of very selective process. I think it's really, it's kind of hard to choose, but I don't think it's that hard. I think the good people generally stand out pretty clearly.
And is that in terms of their technical expertise that show through in their interview or their prior publications?
Funny enough, I think the successful people, I think they are successful in the same way. So it's not only based on their experience, it's really based on who they are. Their intelligence, their personalities matters so much. The passion is so important, but the passion can be developed. Some people just passionate with a lot of things, and some people just hardly to be hardworking or enjoy what they do. So I think personality matters about a lot, and ambition and actually a good access of their own capabilities matters so much. If you overestimate who you are, that's probably going to take on some too difficult project that's going to fail. And if it's too inconfident, there's nothing you can teach a person like to be more confident. They rely on themselves.
Anything to add?
So there's a great book by Angela Duckworth called Grit, and that is really what I look for, I think, in any employee. So you are going to be challenged in this industry. You are going to be frustrated in this industry. I think the best characteristic that you can have, I don't care what your background is, but if you have grit, then you're going to persevere through those challenges. You're going to work your butt off to solve them. You will network. You will be the kind of person that is self-sufficient at solving problems. And that, I think, is the most productive person you can have on a team.
Interesting. So lots of commonalities in what makes a good candidate, both in academia or industry. My advisor actually told me the same thing when I was applying to grad school. Got to show your grit.
Yep.
So worked out. Yeah, so one other question I had, you mentioned, I think all of you mentioned kind of as a leader, you need to be educated, right? So for your various work streams, what sort of resources do you look at to brush up on a new topic or to just get started on one? What do you use?
So from coming from a non-academia environment, we often have to use what resources are available to us. And but that's the beautiful thing is there are so many wonderful free resources that are out there. Coursera, Khan Academy. There's a ton of just opportunities out there that if you are just curious, you don't really have to invest a lot of money. You can just invest your time. So yes, we often encourage folks to take advantage of just what's available for free.
Yeah, for academic research, we primarily read other people's research, which is in the format of publications and so-called papers. So for natural language processing, there are 3 top conferences, NAACL and ACL, so the annual conference for the Association of Computational Linguistics, and as well as EMLP, empirical method for NLP. So these 3 conferences every year publish like several hundred of papers. Of course, we cannot read all of them, but we try to read as much as we can. And for my own group, we hold the group meeting every week is actually to just everyone together read one paper and one of the students present, and we discuss the details. So a lot of paper is just like 8 pages, so a lot of details actually need to talk through in order to fully understand, and sometimes you need to make some guesses of the missing part.
I think too, there's increasing, there's meetups, there's a lot of like UX groups, design groups, things like that. I love the idea of the guild, even though it was all dudes. But I think that's a new thing as well. There are lots of like social, almost organizations that are designed to gather people that are interested in learning these new things, and you can kind of use those to build off of one another. I think that's really awesome and fascinating. So.
You guys hit all my top favorites. Yeah, Wei?
Yeah, just remind me one thing. So actually, I start to see a lot of people in industry going for the academic conference more and more. Yeah. So you probably heard about NIPS, and as well as the conference I already mentioned. So a lot of people in the company just go there. So the conference are very intense. So just within 3 days, you will see what's happening just like in the world just like very quickly. As well as a lot of sponsors actually a lot of companies sponsor all these conferences. You will have booths and recruiters at the conferences too. So that's one place to look for the best people too.
Absolutely. Yeah, I love the kind of theme that we're hearing here about kind of the marriage between academia and industry. I think it's really important. So on that note, a question that I definitely wanted to get your guys' perspective on. So kind of in an emerging field, it can be really hard to assess the latest. There's lots of buzzwords to cut through. And as a consumer of various streams in AI and machine learning, so whether that be vendor solutions, the latest technology, or even kind of a new line in academic research, right? How do you kind of cut through the bullshit, really? There's a lot of it out there, So how do you navigate that? How do you even figure out if it's there at all, right? What do you ask? What do you look for?
So I would just start with evaluating your use cases. Look at where are some real opportunities. What are the big problems that you want to solve within your organization? And start with that. I think that will give you a very real perspective when you look at the various applications of AI, the various ways that you can solve problems, what those opportunities might be. I mean, your solution is probably not going to be the self-driving car. So think about, what problem are you trying to solve, and then what opportunities you have with AI as a solution.
Yeah, the real world problem generally very difficult. Even like cleaning up the data take a lot of effort. So it generally just just difficult. In terms of like various buzzword and algorithms, like for the machine learning side, and for me, it's about just two different algorithms. That's pretty much like what I presented. It's just one line is like this group of algorithm, the other line is the other group of algorithm. The mainstream, there's only two choices. So are either one or the other. So for me, it seemed to be the general framework solution are the same. If you understand one, the core of it is, you just apply it slightly differently for the different problems.
So I have a lot of real world experience with this because we have a lot of vendors that come in both to my boss, the chief medical officer, and I'm sure to the CTO and everything. And I think analytic leaders are in a unique position because you need to be open to accepting new technologies, but you also need to be critical in your evaluation and not just automatically be like, eh. So a lot of times I think that's where the proof of concept comes in. So we know we have questions that we want to answer. We know we want to change, for example, how we deliver care in a particular little population. So I'll have a de-identified data set, and that's fine. I will give it to the vendor, and you do a proof of concept and show me how you can achieve my goal. And that really quickly weeds out, what's the bullshit and whether they can actually deliver.
Great. So kind of along those lines, and I've heard threads of the answer to this throughout the kind of dialogue here, but what do you think one of the biggest misunderstandings is in AI? There's a lot of media hype around the topic, and how, in your opinion, do you see that kind of hindering progress of AI or machine learning within your groups or organizations?
I had mentioned this earlier. For us, it was that AI was going to solve all of our problems.
Yeah.
And that boils down to a lot of what we've been talking about today. It's not a one-size-fits-all. It's not the hammer that's looking for the nail. You really need to evaluate, first of all, the type of problem that you're facing, as well as the data that you have available to assist with making AI a solution. Is it the right application? I think just thinking that it's going to solve world hunger might be our biggest misconception.
Yeah, I think we are always love AI, almost like human being, but at least like together there's a fear of it. You will have like killer robot and it's going to kill us. Or like actually a very interesting concept is like intelligence explosion. So it's once you have an ultra intelligent machine, it will be able to invent and capable to invent themselves and evolve. So at some point when the AI can reach like human level intelligence, they will be kind of creating themselves. So it's going to take off. But I agree with Andrew Ng, one of the leading AI machine learning research, once commented as to worry about AI killing us is kind of like worry about overpopulation on Mars. I felt that's pretty much explained my feelings about it. But I do love all the movies and sci-fi movies. I think it's one day will make a lot of them are turning true, and I think it's going to turn true. It's just a little bit far away.
I think, for me, I think it's just I agree. You have to have a very defined question. And a lot of times you can come in and hear, I just want a report. Can we get an AI to do that? And no. The answer is no. So, I think you have to be disciplined in what problem you're trying to solve. And then, like I said, you've got to really flow out, okay, do we have the data to solve this problem? And a lot of times, especially, you have to think about the executive team is operating up here, and then the operational team is usually way down here. And there's a lot of daylight in between where the quality of data is fudged and what's being done is fudged. And so the analytics team usually has to come in and kind of be the fact checker, right, of what's actually achievable and what we actually do have on hand.
And Katie, I have to add to, so Wei, I think you brought up an incredible point. Yes, there's definitely this fear that AI is going to kill us all, and Elon Musk is not helping that conversation at all. But to make it more immediate, I think there is also a fear that AI is going to replace us. There's a very real fear that it's going to take over all of our jobs, and that's simply not the case. In fact, I think it's going to shift the way that we work. It's going to force us to reskill and retool and take maybe jobs that can be automated with AI and repurpose that very valuable human capital to something else, something different, maybe even more productive and more valuable for the company. So yes, while there's definitely that growing fear that we're all going to die by robots, I do think more immediately there is a growing concern that it's going to replace our jobs.
Yeah, I heard the same thing happened when the industry revolution happened, that a lot of human process, and nowadays it have this streamline like machines to make stuff, There was a fear probably 100 years ago for the same thing.
Yeah.
So, but it just, though the job shift, for example, become a lot of people have the more like white collar jobs.
Absolutely.
So you guys read my mind with the bot talk, 'cause I could not help but having these experts up here to ask them how far away they thought we were from a bot takeover. So I think we've kind of touched on that, right? So we're not, the nightmare in sci-fi movies is not going to unfold anytime soon. But I did hear a lot of what you were saying, that there's a lot changing. I mean, to imagine 40 years ago that a little computer would be my phone here is unthinkable, right? So, I think we mentioned, yes, we don't think bots are going to take over the world soon, but there are a lot of avenues of kind of human behavior and other aspects of our day-to-day thinking process that AI and machine learning, is starting to simulate to an extent. So to kind of close this out here, I'm wondering kind of what kind of, if you think about the human experience, right? Like what portion of it do you feel like we're farthest away from in terms of kind of automating or replacing with a model or an algorithm, right? Is it the human psyche? Is it emotions? Is it personality? What is it? Is it language, which is very complicated? So where do you think we have a lot to go, kind of further in terms of kind of fully realizing this AI-dependent society?
That was a really good question.
That was a lot, yeah,
That
sorry.
was a lot.
Yeah.
I think, Abaya, you really hit on this in your opening remarks, that fully integrated AI. Today our AI is very compartmentalized to do one task or one particular grouping of tasks. But to be able to have AI that can really function across that spectrum, whether it be having emotional capabilities, the cognitive capabilities, the ability to perform a particular action, and do that in a very meaningful way that would not in any way threaten us, but enhance our way of life, I think is something that's still quite a ways away.
Yeah, language definitely is one hard problem. So for speech recognition, so image recognitions, you can sometimes hear people claim that the machine nowadays do better than human. It's, to some extent, that is true, especially like, for example, for speech, there's some people speech with accent. It's not very easy, or like with a noisy background noise. It's actually hard for human, but a machine can do actually better than a single human a lot of times. But for language, it's kind of difficult, and for robots, actually, it's incredibly difficult. You have seen a lot of like great videos showing like various kind of cool robot on like TED Talk or YouTube. You can search for those things. But if you recognize that actually most of the robots developing today, they only can do one single thing. They are never like multiple functional. It's actually, there were like a recent US government supported robotic research. It just asked a robot, a human kind of like shaped robot to step onto a car, drive it, and step down and open a door and drill a hole on the wall. Just in order to do that, this simple process, it normally takes an hour to do for a robot. And only, there's worldwide research participated in this research program. Only several teams, less than 10, was made the robot to be successful to do this whole entire simple process, just open a door, drive a car. And most of robot fall just actually incredibly difficult step is step out of the car. Most of the robot couldn't balance that step and just stop there. So in order to have a multi-functioning robot, we are so far away from it.
I think it's, so there's a great book in my slides there, I put a citation list. There's a great book called Superintelligence by Nick Bostrom that talks a lot about, getting to an actual AI, fully functioning, dimensional AI and what that's gonna look like and where we are. I think another, I think it is the master, kind of that master algorithm function that's gonna be hard. And I think too, we're still dealing with computational and storage. I mean, we actually have kind of almost physical barriers to getting there just in our mathematical models, in our computational power and in our data storage that we'll have to overcome.
Excellent. Well, guys, this has been fantastic. Your presentations were amazing, and I really loved the dialogue here. So to kind of close it out, can everyone just thank our awesome panelists for all their great work?